This video is to present my own ideas on the theory of special relativity, which is well established in mainstream physics. My ideas happen to be against this theory. So, viewers are requested to take this discussion with a critical frame of mind rather than accepting without thought. Comments with a scientific spirit are highly welcomed. In this video, we want to discuss an imaginary clock, which is mentioned a lot in the discussions on the theory of special relativity. This hypothetical clock consists of two reflecting mirrors placed vertically at some distance and a pulse of light reflecting continuously between them. When the light ray completes one cycle from the bottom mirror to the top one and back, it is taken to be 1 unit of time. The following reasoning is often given about the behavior of this clock, and it is established that time passes differently for different observers. It goes as follows. Imagine such a clock is placed in a carriage of a fast moving train. In the train's frame of reference, the clock is stationary. The light ray travels a length equal to double the distance between the two mirrors, and 1 unit of time in this frame is therefore 2 multiplied distance between the mirrors divided by c, the speed of light. But when looked at from the frame of reference of the ground, the ray of light covers a larger distance than double the distance between the two mirrors in every cycle. So 1 unit of time is longer as seen from the ground frame. But there seems to be a problem in this reasoning. Let us see how. The second postulate of the theory of special relativity says that light always propagates at a definite velocity c in vacuum, and further it is independent of the motion of its source. If we look at it carefully, it says that this independence of the propagation of light from the motion of its source must be in terms of both speed and direction of motion. Therefore, the ray of light from the bulb shown here must go and hit at the same point on the roof, whether the bulb is stationary or is moving when the ray of light is emitted. But in the reasoning we just discussed with this imaginary light clock violates this postulate, because when we say that the light ray as seen from the ground frame of reference will move in a tilted direction instead of going straight up or down from the point of last reflection, we imply that the ray is following along the horizontal motion of its source or the point of last reflection, in addition to going upwards or downwards, resulting in a tilted direction of propagation. That means we are saying that the propagation of the light ray is dependent on the motion of its source. That is directly in contradiction to the second postulate, so this cannot be correct. The ray of light cannot move in a tilted direction, just as the ray from the bulb we saw earlier moves upwards only, even when the bulb is in motion when it emits the ray. Because for the ground frame of reference relative to which the train and clock are in motion, the ray of light cannot keep bouncing between the same 2 points on the mirrors. Rather, because of the motion of the clock, the ray each time will hit at a point a little left to the point on the mirror directly above or below the point of its last reflection on the opposite mirror, because this point will have moved somewhat towards right with the mirrors. In fact, after some reflections, the ray will miss the mirrors entirely and the clock will stop working. So how is it that this clock seems to be working fine in the frame of reference of the train but not in the frame of the earth? How can reality be different for different observers? Well, the reality is the same for both the frames. The clock will not work because the light ray doesn't follow along the horizontal motion of the mirrors, which are its source, when it gets reflected each time, between which it is reflecting, besides its usual vertical propagation, according to the second postulate, and hence it will miss them after a few reflections. Hence, this imaginary light clock cannot work when it moves. Further, we see that the independence of the propagation of light from the motion of its source makes the notion of absolute motion meaningful relative to the space of the universe. Because if such a clock is at rest relative to the space of the universe, it will work fine, and if it is moving, it cannot work because light propagates freely in space. Now, since the notion that the time propagates at different rates in different frames of reference in relative motion is based on the flawed reasoning about this light clock, because it implies that the light ray, apart from moving vertically between the mirrors, follows along the horizontal motion of these mirrors as well. The notions of time dilation and length contraction have to be dropped. Time and space are absolute quantities, regardless of the frame of reference. So, we conclude that the theory of special relativity is logically inconsistent. If you like the ideas presented here, you are welcome to read my article on special relativity. The link is given in the description below. Thanks a lot for watching.